Overgeneralization is where you do a study on one group and you try to say that it will happen to all groups. As an example, in doing cancer treatments on rats, just because the treatment works on rats does not mean it will work on humans. Another example is that until recently, most FDA medication testing had been done on white males of a particular age. So there's no way to know how the medication affects other genders, ethnic groups, age groups, or races. So the new FDA guidelines stress using individuals from different groups. Cause and effect is another big place where students and even people who publish articles make mistakes. Cause and effect is where the people decide that one variable causes the other just because the variables are related or correlated. So unless the study was done as an experiment, where a variable was controlled, you cannot say that one variable caused the other. Most likely there's another variable that caused both. So as an example, there's a relationship between number of drownings at the beach and ice cream sales. As the number of drownings increases, so do ice cream sales. This does not mean that ice cream sales increasing causes more people to drown. Most likely the cause for both is just increase in the heat. So as it becomes hotter outside, more people are swimming, so more people are drowning, and more people are eating ice cream when it's hot outside. So to make a connection to earlier, if we do an observational study, from that we can show correlation between variables. We must do a designed experiment if we want causation, if we want to be able to say one particular thing causes another to happen. And then sampling area. So this was mentioned earlier in this chapter as well. So this is a difference between the sample results and the true population results. So again, this is unavoidable, and the results in the fact that samples are different from each other. So as an example, if you take a sample of 5 people's heights in your class, you'll get 5 numbers, and typically we would then compute an average of those numbers to get a statistic. If you take another sample of 5 people's height in your class, you'll likely get 5 different numbers. Some of them might be the same, but probably not. And again, if you average these numbers, you'll probably get a different average than the average of these 5 numbers. So again, much of the area when we start doing inferential statistics will focus on studying sampling error and how much of that we can actually expect to happen in a given study.